Hi everyone. So in this video, we're going to be talking about angles, which we'll see are very, very important in this class. It's a really kind of fundamental concept that is going to come up all throughout the quarter. So before I get into that, I just want to quickly mention that, so notice at the top it says 6.1. When I write at the beginning of a video a number in a box like this, that refers to the chapter and section number in the textbook for this class, so that if you want to follow along, that would be the place you would look. So in this case, it would be chapter 6, section 1. Also, I just want to quickly mention that the way our book is set up, chapters 5 and 6 kind of present very similar material, but in different ways. And so they're meant to be able to be taught in either order. And so what we'll actually be doing is kind of going back and forth a little bit between chapters 5 and 6. So I just don't want you to be thrown off when we suddenly are doing something from chapter 5. We're not really going backwards. We're just kind of going back and forth. Okay, so we talked about angles, in our last video, right? Because we were talking about triangles, and triangles contain angles. So I want to give you kind of a more formal definition of what an angle is. And in order to do that, there's a couple of other things I need to define. So you'll see that in the definition of an angle, we're going to use this word ray. And so I want to define what a ray is. And in order to define what a ray is, I want to compare it to a line and a line segment. So there's kind of three different terms we're defining here: a line segment, and a ray. Okay, so what is a line? Well, a line, you might think of, something from algebra, y is equal to mx plus b. It's this shape where it always has the same slope. It has a straight shape to it. And the thing about a line compared to a line segment is that it goes on forever in both directions, right? If you graph a line, in an algebra class, you might put like an arrow on each end to represent that it keeps going and going. A line segment, on the other hand, is like a little snippet of a line. So it has an endpoint on each end. It does not go on forever. You could measure its length, right? It's finite. A ray is like somewhere between these two. So a ray is an object where one of the ends is a finite, has an actual endpoint, but then the other end points off infinitely. So it kind of goes off in only one direction. So by the way, we're not really going to be using these words in this class very much. This isn't very important. It's more something that I just need to get out of the way in order to give you the definition of an angle. Okay, so what is our formal definition of an angle? So an angle consists of two rays joined by a common vertex, so a common point. So let me kind of sketch an example down here, and then I have a little bit more to write about what an angle is. So when we say two rays, we're basically referring to the fact that an angle, it could go on however far you want to in these two directions, but the two rays are joined together at this point to form the angle. So the measure of an angle, so, usually when we're talking about angles, we're talking about, it's a 60-degree angle or a 30-degree angle, whatever, measurement of it. And that basically refers to the amount of rotation from one ray to the other. So you may not have thought of angles previously as rotation, but hopefully that kind of makes sense to you, right? Like picture taking this line or this ray at the top and kind of pulling it down to the one on the bottom. And then if you were to pull it back upward, you're really kind of rotating it, right? Think of like clock hands, right? They're rotating compared to each other. So the measure of an angle is the amount of rotation from one ray. So that first ray, the one on the bottom, is called the initial side. And I'll label that in a moment. To the other ray. and that ray is called the terminal side. Oops. Okay. So here's our angle, right? We have two rays connected together. So in this picture, the side on the bottom here, this would be called the initial side. And this would be called the terminal side of the angle. And then the angle itself is really referring to the amount of rotation that it would take to go from the initial side to the terminal side. By the way, I know there's a lot of new vocabulary here. This definition probably feels a little bit overly complicated. I don't want you to worry too much about this precise definition. We are going to be using the words initial side and terminal side, so you do want to be aware of those two phrases. And then the other thing I want you to take away from this is this idea of measuring a rotation, right? The idea of thinking of an angle as an amount of rotation. So frequently when we're talking about angles, if we want to refer to a generic angle, we often use the Greek letter theta. So theta looks like basically a capital O with a little line through it, or a zero with a horizontal line through it. And it's just a variable. It's kind of like if you had a triangle and you referred to the sides as A, B, and C, right? Those are just like labels for the sides. Similarly, for triangles, for angles, we frequently label them with theta. So let me just write that down here. So it's a Greek letter. And I'll spell it out too. So it's theta, if you were to write it down, is frequently used to label angles. And we'll sometimes use other variables as well, but this is kind of the most common one. So one other thing we need to know about the way that angles are measured is, again, with this idea of rotation has direction to it, right? And so the way that we're going to kind of distinguish between those two directions that you can rotate things, right? You can either rotate things clockwise or counterclockwise. And so when you have an angle that is measured positively, so for example, an angle of 40 degrees or an angle of 75 degrees, those are positive angles. That would mean something that looks like this picture here. So that would mean that you're measuring the angle in the counterclockwise direction, right? So if the rotation is counterclockwise, that means that the angle is positive. And I'll draw an example of this below in a moment. So counterclockwise is a positive angle. If instead the rotation is clockwise, so the opposite direction of the arrow that I drew above, then that would refer to, or that would correspond to, a negative angle measure. Okay, so just to give a quick example, if you had an angle that was measured using a positive number, so something like 70 degrees or something like that, that would look like this. That would mean that you're measuring in this direction. So this is a positive angle. And then measuring in the negative direction would mean that, again, you have your initial side here, but now instead of rotating counterclockwise to get the angle to kind of place your terminal side, instead you're now rotating clockwise. So something like this. This would be a negative angle. And we'll see that depending on what the angle measures are, these could look very different, but the important thing is the direction, right? So positive means you're rotating counterclockwise, negative means you're rotating clockwise. Okay, so I want to look at some examples of important angles. So basically, like I said, we're going to be working with angles a lot in this class, and there are certain angle measures that you just really want to be kind of familiar with what they look like. And so most of these, I think you probably already have some kind of gut feeling about what they look like. But if not, this is a good time to focus on getting used to these. So the first one that I have drawn here, this we talked about in the last video, this is a 90-degree angle. So we talked about how in the last video, oftentimes you denote that with this kind of square. For the sake of drawing things with the rotation, I'm just going to draw an arrow. So this would be a 90-degree angle or a right angle. This next one, if you have an angle where it's all the way open, so kind of just like a straight line, this would be a 180-degree angle. So this next one kind of doesn't look like an angle at all, but this is meant to represent a 360-degree angle, right? So this is like you had your initial side, and then you're taking your terminal side and you're spinning it all the way around so that it comes back to its starting point. So this would be 360 degrees. You might look at this picture and say, wait, I think it kind of looks like it's 0 degrees, right? It's almost like you didn't do any rotation at all. We'll get to that in our next video. So it's possible to have different angles that kind of look the same. Those are what are called coterminal angles. So that's something we'll get into in our next video. But for now, I just want to kind of think of this as being a 360-degree angle. Okay, so this next one, these next three are probably not perfect, but this next one is meant to represent a 45-degree angle. So 45 degrees is half of 90 degrees. So that's the way I would visualize it, is just take your right angle, which I think is much easier to picture, and just picture cutting that in half. And that is what a 45-degree angle looks like. Last two that are important to know is a 30-degree angle. So we saw some of those in our last video. So 30 degrees is 1/3 of 90. So that's a way you can kind of visualize that. And then the last one is 60 degrees. So 60 degrees, I'm trying to think what color I didn't use yet. Maybe this one. 60 degrees is 2 times 30, or you can think of it as being 2/3 of 90. So this would be roughly what a 60-degree angle looks like. So these angles are just going to come up a lot. So you just want to have some kind of quick familiarity with these angles. Okay, let's do some practice with sketching some angles. So kind of using what we know in terms of what these angles look like and kind of seeing how we might use these familiar angles to sketch some other angles. So we want to sketch 120 degrees, -30 degrees, and 405 degrees. So when I say sketch them, basically our pictures are going to look something like these, right? We're going to have an initial and a terminal side, and then draw an arrow to represent the rotation. So I'd recommend pausing the video at this point and trying this yourself, and then coming back to see how it goes. Okay, so let's start with 120. So I'm going to start by, and this goes for all of these, you can start by just drawing your initial side. And then we want to think about, what does 120 degrees look like? So how can we kind of think about 120 degrees in terms of these like more familiar angles? Well, the way I would probably think about it is that 120 is 30 degrees further than 90, right? So it's going to be bigger than 90, and it's going to be bigger than 90 by about 30. So it's basically like if we took this angle here and put that much more rotation on this first picture. So, it's going to end up something like that. So that's what we want to make it look like. So it's not going to, this would be 90. It's not 90. It's going to be 30 degrees more. So probably something like this. That might be a little big, but it's roughly correct. So this would be 120 degrees. Okay, so next up we have a negative angle, -30 degrees. So again, we always want to start by just sketching our initial side. So what would -30 degrees look like? Well, the negative sign tells us that we're rotating clockwise. And so we want to rotate clockwise by 30 degrees. And so we know what 30 degrees looks like. It looks something like this amount. And then the rotation in this case is clockwise. So this would be our angle, -30 degrees. Okay, last of all, we have 405 degrees, which I think is kind of the funkiest one of these three. So what does 405 degrees look like? So let's start by drawing again our initial side. Okay, so 405 degrees. The first thing to notice, kind of like when we did 120, we compared it to 90, right? And we were like, oh, it's a little bit more than 90. 405 is pretty big, right? It's bigger than 360. So what that tells us is that this angle is going to represent going all the way around in a full rotation to 360 and then a little bit further. So we want to figure out how much further it is than 360, right? So 405, well, 405 would be equal to 360 plus 45 degrees, right? And so what that means is that when we go to draw our angle is going to involve starting at this initial point, going counterclockwise all the way around in a circle. So if I stopped here, that would be 360. It's then going to keep going 45 degrees more. So our picture is going to end up looking just like a 45-degree angle, but it's not actually the same as a 45-degree angle. And this, again, is something we'll get more into in our next video. The reason it's not the same is because 45 would just mean that we're just turning that 45-degree angle. 405 means that we're going all the way around in a circle and then an additional 45. So when I'm teaching this in person, I actually demonstrate this by like spinning around in a circle. And again, that's why I like to think about angles as rotations, because it really kind of points out how, depending on kind of how you're rotating and how many times you're going around in a circle, it's describing a different motion, even if the picture kind of looks the same. So even though this picture looks the same as a 45-degree angle, the motion associated with this angle is actually different. Okay, so far we have talked about angles using degrees. So degrees is, I think, kind of the most intuitive way of measuring angles for most people. I think that's probably what you kind of learned first in school. If you're talking about like, a jump that you do in like ice skating or whatever other sports involve, jumps like skiing or snowboarding, you would say like a 360, right? Or something. You give the angle in degrees. But it turns out that there's actually a better system for measuring angles, and it's the main system we'll be using in this class, and it's what's called radians. So a big part of what maybe makes this class challenging is being able to use radians when measuring angles and being able to be really comfortable with radians. So in this video, as well as especially in the next video, we're really going to focus on kind of getting comfortable with radians, because I want you to get to the point where even if degrees are still the more intuitive measurement for you, I want you to be really comfortable with radians because they are the main unit we're going to be using in this class. Okay, so radians. So what are radians? So radians are basically just a different unit for measuring angles. So let me make this thinner. So radians are a unit of measurement for angles. So they're basically a way of measuring angles. And we'll see that in some ways they're actually kind of a more natural way to measure angles than degrees are. So that's something we'll see in like the next couple of videos. So the main kind of conversion you need to know, like I said, radians are a unit, right? It's kind of like inches versus centimeters, radians versus degrees. And so typically if you are kind of trying to go back and forth between two different units, you need to know what the conversion is, right? You need to know how many radians are equal to how many degrees. And so here's the main conversion you need to know for radians and degrees is that 180 degrees is equivalent to pi radians. And so when I write down pi, I literally mean the number pi, like 3.14 ... So the thing about radians that we'll see is that they are oftentimes measured in terms of pi. So multiples of pi, fractions of pi. And it's basically because 180 degrees is equal to pi radians. So we'll see that most of our kind of friendly, familiar angles can be expressed as, like pi over 4 or 3 pi or, different multiples and fractions of pi. Okay, so using this fact that we just established, the fact that 180 degrees is equivalent to pi radians, I want to do just a couple of quick, easy conversions, and then we'll get into some more kind of complicated examples. So first thing I want to do is convert 360 degrees to radians. So we know that 180 is pi radians. So what do you think 360 degrees should be? Well, it should be twice as much, right? So we know that 360 degrees is 2 times 180 degrees. So 360 degrees should be equal to 2 times pi radians. So 360 degrees is equal to 2 pi radians. Okay, so similarly, let's say that we were given an angle in radians, and one thing that I did here that we'll be doing kind of more frequently throughout the class is not writing down the word radians. So I could have written this as pi over 2 radians. That would be fine. And I'll change that for now. But one thing I want you to get used to is that when we're talking about angles, if there's no unit mentioned, you should assume that it's radians. So typically in this class, when we're talking about an angle in radians, we'll say something like the angle is pi over 3. The angle is 3 pi. The angle is 3 pi over 4, without actually saying the word radians. So especially if you see the pi in there, that's kind of a signal that we're talking about radians. Okay, so what would pi over 2 radians be? Well, let's kind of use the same reasoning we used in the last one. So we know that 180 degrees is pi radians. So what should pi over 2 radians be? Well, pi over 2, let me change color here. Pi over 2 is half of pi, right? Like that's what dividing by 2 means. It's half of it. So if pi is equal to 180 degrees, then what should pi over 2 be? Well, it should be 90 degrees, right? Because 90 degrees is half of 180. So hopefully that kind of makes sense. Like just knowing the fact that 180 degrees is equal to pi radians, if we're working with angles that are simple multiples or fractions of 180 or of pi, we can easily convert them without even really writing down any computations, more kind of in our head. But we'll see that we also want to be able to deal with conversions that are a little bit trickier. So I want to talk about how you can always convert any angle between degrees and radians. So before we get into that, I actually want to talk about how to do angle conversions in general, because if you understand how to convert units in general, you'll understand how to convert units with degrees and radians. So in general, when you want to convert from one unit to another, actually, I don't need to write in general again. I already wrote that. So to convert from one unit to another. So for example, as we'll do below, let's say you're trying to go back and forth between inches and feet, or even, like centimeters and inches, degrees, not angle degrees, but temperature degrees, degrees Fahrenheit and Celsius, anything like that where you're kind of converting between units. What you can generally do is, and actually I take it back, this method does not work for Celsius and Fahrenheit because those are a little different, but don't worry about that too much. In general, to convert from one unit to another, you can multiply by basically whatever number of your new units is equivalent to a different number of your old units. So I know the way I'm writing that is potentially confusing. I hope it's not confusing. But basically what I'm saying here is, like, let's say, and we'll do this in a moment, let's say you're talking about inches and feet. 12 inches is equivalent to 1 foot, right? So when I say A and B here, I basically mean like 12 inches, 1 foot. Whatever the kind of equivalent amount is in your different units, that's what A and B represent. And then what you want to do is you want to put your new units in the numerator, and then your old units in the denominator. And so the reason that this method works is because, and we'll see this in action in a second, well, when you're multiplying by two things that are equivalent, right? Let's say you're multiplying by 12 inches over 1 foot. 12 inches and 1 foot are equal to each other. And so you're not changing your number when you multiply it by the same thing over the same thing, right? It's kind of like, when you're trying to make a common denominator, you multiply by like 3 over 3 or something like that. Because you're choosing to make your numerator and your denominator equivalent amounts in different units, when you multiply by this fraction, you're not changing the value of the thing you're trying to convert. And then the other reason that this works is because the old units will cancel out and you'll be left with your new units. So let's actually see what this looks like in an example. So for example, if you want to take 27 inches and convert it to feet, you can multiply it by, so we want to put our new units on the top. So the top is going to be feet, and our old unit on the bottom. So our old unit is going to be inches. And then we just want to put the equivalent amounts. So 1, I guess I should write foot, over, I'll just write FT, just be nice and ambiguous here. So 1 foot over 12 inches. And so see what happens is that the inches cancel out. And so what we're left with is 27 over 12 feet. And I think that can be reduced. So that would be, both of these are divisible by 3, right? So we could divide the numerator by 3 and we'd get 9, divide the denominator by 3 and we get 4. So it's 9 over 4 feet. And then similarly, let's say we want to convert 4 feet to inches. Well, this one you might be able to do in your head, but let's still kind of go through the motion so we can see how this works out. Well, what would you do? You would put the new units in the top. So we would put 12 inches in the top and we would put 1 foot in the bottom. And so we can cancel out the feet and we're left with 4 times 12 is 48 inches. So I just think this is a really useful principle to understand in terms of unit conversion in general, and we'll see that we can really make use of it here. So using this idea, if we want to convert from degrees to radians, so what would we want to multiply by? If we're trying to go from degrees to radians, and let me actually make this a little bolder. So if we're trying to go from degrees to radians, we want to put our new units in the numerator, right? So that would be radians in the top, and then degrees in the bottom. So I'll just put the little degree symbol. And so what is our kind of equivalency here? Well, we know that pi radians is equivalent to 180 degrees. But really, when you're doing this conversion, you don't want to write the word radians. So I'm just going to rewrite this as pi over 180. But really, it's the same as pi radians over 180. It's just that we're not writing down the word pi. So for example, with this example we have here, if we're trying to convert from 75 degrees to radians, we would take 75 degrees and then we would multiply that by pi over 180 degrees. And so as we saw in the earlier example, the units cancel out, the old units, and we're left with now 75 over 180 times pi. And so this can be reduced. Let's see. So the numerator and denominator are both divisible by, let's start with 3, right? We can divide the top by 3 and that would give us 25. And then the bottom divided by 3 gives us 60. But then we can even reduce this further, right? So these are both divisible by 5. So if we divide the top by 5, we're left with 5. Bottom by 5, we're left with 12. So we're left with 5/12 pi. So the way that you would express 75 degrees in radians would be 5 over 12 pi. Okay, so what about to convert from radians to degrees? Well, basically you're going to do the same thing we did from when going from degrees to radians, but just flip over the way you're multiplying, right? So same idea we saw with inches and feet. we want to put the new units in the numerator. So in this case, that's 180 degrees. And then the old units in the denominator. So that's pi. We're not writing radians, but it is pi radians. So if we wanted to convert 5 pi over 4, sorry, I didn't write from, or I guess I didn't need to write it. So convert 5 pi over 4 radians 2 degrees. So what would this look like? Well, we'd take 5 pi over 4 and we'd multiply it by 180 degrees over pi radians. And so the units of radians themselves, those would cancel out. We didn't write them down, but if we did, those would cancel out. And then the other nice thing is that these pi's actually cancel out. And so we're now left with 5 over 4 times 180, or 5 times 180 over 4. So if you were to multiply that out, you would get 225 degrees. So one more example. So far when we've seen angles measured in radians, we've been, they've always had pi in them. They don't have to. So we'll see in this class, in general, most of the time that we're measuring angles using radians, there will be a pi in the angle. And that's because pi radians is equal to 180 degrees. And in this class, we'll mostly be working with nice angles that are like clean fractions or multiples of 180 degrees. So for example, 90 degrees is pi over 2, or 30 degrees, that's 1/6 of pi, that's pi over 6. So that's the reason that most of our angles will have pi in them. However, there's nothing wrong with having a radian angle that doesn't have pi in it. So all that means is that it's not like some clean, nice multiple or fraction of 180 degrees. So this is an example. This says 3 radians. So let's convert 3 radians to degrees. So how would we do this? Well, we do it exactly the way that we did the earlier examples. So we'd take 3, and if you want to, you could write out the word radians, and we're multiplying that by 180 degrees over pi. So there's no pi to cancel out this time, and that's okay. Like I said, if we wrote the word radians, we could cancel those out. We have effectively changed our units into degrees. So now we can multiply these together. So if you were to multiply these together, you would get 3 times 180 over pi degrees. And so let's actually type this into a calculator and get an approximation. So this would be approximately equal to 171.89 degrees. So I want to pause and think about, like, how can we make sense of this answer? We mentioned how 3 radians it's a little bit weird because it's not a multiple of pi, but we can still compare it to pi. So how does the number 3 compare to the number pi? So pi is equal to about 3.14, right? And so 3 is just a little bit less. And so it makes sense that our answer in degrees is just a little less than 180. Right? So I'm going to write that down because I think that's a really important kind of way to be able to make sense of your answers. So this makes sense because 3 is just a bit less than 180, right? And we know that 180 degrees, or sorry, just a bit less than pi. Right? 3 is a little bit less than 3.14. And we know that pi radians is equivalent to 180 degrees. So it makes sense that our answer, 171.89 degrees is just a bit less than 180. All right, so that is it for this video. In our next video, we're going to be spending some more time talking about angles and radians. So we're going to try to really get more comfortable with working with radians and kind of being able to feel kind of fluent in radians so that we're not always converting them back and forth between radians and degrees. And then, as I mentioned, we're also going to talk about this concept called coterminal angles. So I'll see you all in the next video.